Okay, this question is about chemical equilibria. Nitrogen monoxide and oxygen react to form nitrogen dioxide. NO2 in the reversible reaction shown. A chemist investigates the equilibria. The chemist mixes, okay, so I've just spotted this. So down here, I'm going to give myself a little reminder. That's got to be to 3 significant figures. So that's my exam technique there. So I've got 2NO plus O2 in equilibria with 2NO2 now. So the ratio is in the equation. The initial amounts, so I've got 1.6 of this and 1.5 of that and none of that at the start. So I'm told that 75% of the NO has been converted, so 0.75 times 1.6 is 1.2, so the change is 1.2. So at equilibria I have 0.4. So it's a 2-to-1 ratio to here, so if the change here is minus 1.2, it's going to be minus 0.6 there. So at this point I'm going to have 0.9 moles of that, and then from here to here it's a 1-to-1 ratio, so plus 1.2 moles here, so 1.2 there. So all of those will get you one of the marks. So I've got my amounts at equilibria. Now I need to calculate Kp, so I'll need the total number of moles. So let me add all of those together. So 0.4 and 0.9 and 1.2 is 2.5. So that's the total number of moles. So at this point here, I'm just going to work this through now. So the mole fraction is 0.4 over 2.5, 0.9 over 2.5, 1.2 over 2.5, and then the partial pressure. So I've got the total pressure up here, so I need to multiply each of those by 1.21 times 1.21 times 1.21. So my partial pressures for each of these is 0.1936, 0.4356, and then 0.5808. So 2 further marks here, one for working out the total number of moles, one for then using that to get all of the partial pressures. The fourth and final mark then is for calculating Kp. So Kp is the partial pressure of NO2 squared over partial pressure of NO squared times the partial pressure of O2. So that is 0.5808 squared over 0.1936 squared times 0.4356. That gives us an answer of 3 significant figures. Here's my reminder here. So 20.7. Okay. Part 2, the chemist then repeats this. So let me get the equation down here so I know what I'm doing. So 2NO and O2. So 2NO plus O2 equilibrium with 2NO2. And the enthalpy change is minus 114. Minus 114, so it's exothermic in that direction, so endothermic over here. Okay, and then Kp is obviously products over reactants, so I'm just going to use that to help me with all of this. So complete the table to show the predicted effect of each compared with the original experiments. Only use the word greater, smaller or same. Well, we know that only temperature affects equilibrium constants. So it's going to be the same here and the same here. And if I increase the temperature, it's going to go to this side here. So looking at my products, then my products is going down. So this is going to be smaller. Okay, let's do the rates of a reaction because that's going to be the next easiest. So if I increase the temperature, the rate will be greater. If I increase the pressure, the rate will be greater. And if I add a catalyst, the rate will be greater. So all of these are going to increase the rate. The equilibrium amount of NO2, so let's work these out. So if I increase the pressure, I've got 3 moles of gas over here and 2 moles over there. So if I increase the pressure, the equilibrium is going to go that way. So increasing the pressure means, so products goes up. So this bit here is going to be greater. I've not done temperature. Well, temperature is kind of, I've already said that Kp is smaller, which means it's going in the reverse direction, which means that the product will be smaller. And then if I add a catalyst, that has no effect on the position of the equilibria, so that is going to be the same.